I'm going to explain exercise 12 from the exercises of hyperbola. The problem asks for you to find the general equation of the hyperbola whose center is at 1, 3, whose transverse axis it's parallel to the x-axis, whose eccentricity is 5/4, and it has a lattice rectum of 9/2. So to do this, guys, first thing, if I graph my point at 1, 3, and I identify that its transverse axis, it's parallel to the x-axis, you should identify that it's a horizontal hyperbola because the transverse axis would be this one, and that would be parallel to the x-axis. Okay? So, to do that, we would need to use this equation, x minus h squared over a squared minus y minus k squared over b squared. Now I have h and k, but I'm missing a and b. So to find a and b, we need to use the eccentricity that they give us and the lattice rectum. So I know that the eccentricity is c over a, and I know that it's 5/4. So c over a is equal to 5/4. And then I have another equation, which is the lattice rectum, which is equal to 2b squared over a. And I know that it's 9/2, so I'm going to have that 9/2 it's equal to 2b squared over a. I have two equations, and I need to isolate one of the variables from here. And then I would isolate b squared from here so that I can use a condition and substitute. So I can isolate c from here, and I'm going to get that c is equal to 5a/4, because if this is dividing, I take it multiplying to the other side. And on this side, if I leave b squared by itself, then you know that 2 times that my a is going to go multiplying to the other side, and you're going to have 9 times a, and the 2 is going to divide, so it's 9 times a/4. I use the condition, which is 6 squared equal to a squared plus b squared, and I substitute what I found. So c would be 5a/4, but this, it's squared. And b squared is already 9a/4. I multiply, 5 squared, and a squared would give me 25a squared, and 4 squared would give me 16. And then I multiply everything by 16. To eliminate my denominators. So if I multiply this one by 16, I would get 25a squared. This one by 16, 16a squared. This one by 16, you would get 4 times 9, which is 36a. And then I pass this one subtracting to the other side, and this one subtracting to the other side, and I end up with 9a squared minus 36a equal to 0. If I factor 9a, I get that 9a times a minus 4 is equal to 0, and therefore a can be equal to 0 and a can be equal to 4. Now, since a is the distance from the center to the vertex, it cannot be 0. So this is not an option. So the only one that I will take into consideration is a equal to 4. By knowing that a is equal to 4, then I can go back to the equations that I had at the beginning and substitute to find the other variables. So if I substitute in that one the value of a, I would have 9 times 4 divided by 4, and that gives me 9. So that means that b would be 3. Substitute also the value of a in c, I would get that 5 times 4 divided by 4 would be 5. With that, I found the value of a, the value of b, and the value of c. And then I can just substitute these values into the equation that will allow me to have the general form of the horizontal hyperbola. So a is 4, so I would have 4 squared. B is 3, so I would have 3 squared. And then I need to multiply everything by the common denominator, which is 144. So 144 times this, 144 times this term, and 1 times 144. 144 divided by 16 is 9. 144 divided by 9, it's 16. And then you need to expand this binomial. So x minus 1 squared is x squared minus 2x plus 1. Y minus 3 squared, it's y squared minus 6y plus 9. 9 times x squared, 9 times all of this parentheses, and negative 16 times all of this parentheses gives me all of this. And then I take this 144 subtracting, they're going to eliminate each other. And you end up with the equation 16y squared minus 9x squared minus 96y plus 18x minus 9 equal to 0. Or you can express it as 9x squared minus 16y squared minus 18x plus 96y plus 9 equal to 0. These, whichever one of these, is the general equation of the hyperbola that satisfies the conditions that they're giving you.